Okay, welcome once again to a tutorial on the KARNAUGH map. And back to where we left in the previous tutorial. I said I'd just show you how to fill up a KARNAUGH map. Okay, so let's say you have a function. All right, so I'm just going to write that down over here. You have a function f. Now let's say that f is given by in somewhat this way. It's given by sigma small m. And then we got the certain numbers inside that says 3, and then we got 4, 5, and then 7, and then we have 9, okay, and then we got 13, okay, 13, 14, and 15, okay. There you go. So let's check it up together. Okay, 3, 4, 5, 7, 9, okay. And then we got 13, 15, and 14. All right. So with this particular function, as I'm just going to show you over here. So let's say we got this particular function. All right. And now we need to, before jumping onto the K-map section, we need to just determine what sort of K-map, or rather, what's the size of the K-map that we require in order to accommodate this particular function. Now we can see over here that the the highest value of we can basically see that the highest value of the numbers that are given over here consists of 15. That's the highest value. So it's quite clear that we require at least 16 cells in order to just accommodate all this data in the K-map. I mean, in order to accommodate this particular function, we need at least a K-map that has a 16 cell capacity. So which means that we require a 4x4 K-map. And what do these numbers actually signify? Yeah, you're right. Each of these numbers actually represents the cell numbers in the K-map. Okay, so I showed you back in the previous tutorial that each of the cells in the K-map are designated by some numbers. So these are the cell numbers, okay, and they are just included in the function to show that which of the cell numbers would be required to be filled up. Okay, so and furthermore, before we move on to our K-map, we can also need to determine that whether the function is an SOP or whether it's a POS type expression. So whenever we see a sigma sign in a function, then it's quite obvious that it'll always be an SOP type function. And for an SOP type function, as I said earlier, a 0 represents a complementary value. I mean a complementary variable, okay? Whereas a 1 represents a non-complementary variable. So wherever we're just we go to the KARNAUGH map section, and let's just draw a 16-celled KARNAUGH map right over here. Okay, I'm just gonna draw it right over here. Just kind of like hold on with me for a second there. Okay, so it needs to have 16 cells, so we need to have 4 rows and 4 columns. Okay, there you go. We have 4 rows, and now we need 4 columns. 1, there goes 2, and there we have the columns 3 and 4. Okay, so now again we need the binary values over here. All right, and then we also need them for the rows. Okay, there you go. And let's just designate the variables with A, B, C, D. Okay, and now let's just number up the cells together. So that's 0, 1, and then 2, 3. Then we got 4, 5, 6, and 7, and then we got 8, 9, 10, and 11 over here, and then finally 12, 13, 14, and this one's 15. Okay, so now we got our K-map. So if we just take a look back at the function over here, so whichever cell number is present in the function, we should always keep in mind for an SOP type function, we should always fill up those particular cells which are present in the function with 1s. Okay, so now we have the cells 3, 4, and 5. Okay, let's just fill it up. I'll use a different color. Okay, so cells 3, 4, and 5. So 3, 4, 5. And then we have the cells 7, 9, and 13. 7, okay, then 9, and then 13. And then we need, 14 and 15. All right, so now we have just filled up our KARNAUGH map. And now what do we do? Okay, after filling up the KARNAUGH map, we are supposed to group together the ones that we got in the that's just spread all around in the K-map over here. We need to group these ones into pairs, okay, or quads. And you can also group them up into groups of 8, okay. So if you have 8 ones together, then you'll always group them up, okay, to form a larger group over here, okay. So you can always group up ones the ones that are present over here in groups of 2, okay, and then groups of 4, and then groups of 8. All right, so you can get to see a correlation based on the grouping system. We always group the ones into powers of 2. So if you're just basically grouping them up into pairs, then you're just grouping them up in 2 to the power 1 type of groups, okay. So if you're just grouping up grouping them up into groups of 4 or quads, then you're basically grouping them up into 2 to the power 4 type of groups, okay. And if you're just grouping 8 ones just together, then you're grouping them up into 2 to the power 3 type of groups, okay. So we just always group them up into some power of 2, okay. So that's how you should group them up. All right, so now we can see that the cells they're not 4, 5, 7, 15 and 13, they all just form a quad, okay. So we can just group them up together, okay. And now we can also see that the cells 3 and 7, they can form a group of 2, all right, a pair. And then similarly cells 4 and 5, and then 15 and 14, and finally 13 and 9, they can also form a group of 2. Okay, so now that we've just finished grouping up the ones together, so that's how basically you can just fill up and then you just group them up. Now what we are supposed to do is that I'm just going to introduce you to certain terms over here. Now you can see that for the pairs of groups constituted by the cells 3, 7, and then 4, 5, and then 13, 9, and 15 and 14, for all these groups of 2, or rather the pairs that have been formed over here, you have at least a single cell that cannot be grouped with any other ones which can be basically present around it, okay. Now it's always to be kept in mind that whenever you're just grouping the ones together, then you always group the adjacent cells that lie adjacent to each other, either horizontally or vertically, okay. No diagonal grouping is ever allowed in the Karnaugh map system. So you can always see you can get to see over here that the cells 3, 4, 9 and 14, for all the pairs that have been formed over here, they cannot be grouped with any other ones that could be just present around it, okay. They cannot be grouped because they have no other ones present around itself. So such kind of groups are basically referred to as EPIs, okay, or rather essential prime implicants, okay, essential prime implicant, just known that way, okay. And then you got this quad right over here, okay, and each of its ones can be grouped with other EPIs, okay. So all the pairs that we have got over here, all of them have at least a particular cell, or rather a particular one, which cannot be grouped with any other ones because no other ones are present in their vicinity, okay. Basically adjacent to them. So what we can see over here is that we have 4 EPIs, okay. And now this quad that we have just formed in the center, this particular quad, in that particular quad, each of its elements, that's each of its ones, are basically being shared with 4 EPIs. So each of its elements being shared with EPIs makes this particular quad what we call as an RPI, okay. We just call such kind of a group as an RPI, which means redundant. It's writing it down over here. That means redundant prime implicant, okay. All right. But if we were to have such a kind of system, or rather if in the Karnaugh map over here we never had the cell 9 filled up, Okay, if the cell 9 was not present in the function, and despite that, I mean, instead of having the cell 9, we had the let's say the cell let's say 12 filled up with a 1. So in that case, if we just try to group the cells 12 and 13 up together, then we can also see that we can form a prospective group between the cells 4 and 12. Okay, so in that case, this particular quad right in the center would not be an RPI any longer. Okay, and similarly, the pair that's just been formed with the cells 12 and 13, they would not form a an EPI anymore. So whenever you have such a group that's not, whose ones are just being left alone so that they can be just shared with any other ones adjacent to them, if they don't have any ones adjacent to them, then we just call them selective prime implicants, that's SPI. So we have here the cells, if we just group the cells 4 and 12 together, then we can just call this one like as you can see over here as an SPI, okay, or rather as a selective prime implicant. All right. So similarly, the cells 12 and 13 also forms a selective prime implicant. So it all depends upon how you just group the cells together. So whenever you have such situations and they ask you to find the EPI, RPI, and the SPIs in a particular Karnaugh map system, then you just do it something like this. Okay, so this is how you can just fill up a Karnaugh map with a function that's just given in the SOP form. And now I'll just show you how to group a Karnaugh map with a function that's just given in the POS format. So in the POS, functions are just designated with the pi symbol in front of them. So you have a capital M over here, and let's say it contains the cell numbers 1, 2, 3, and then you got 6, 7, and 8 and 9, and then you got 12 and 14. Okay, let's say we have a POS function, okay, with that's designated with the pi symbol over here. So whenever you see this, just keep in mind that this is a POS function that you're dealing with. Okay, and let's say we got a cell numbers from 1, 2, 3, 6, 7, 8, 9, 12, and 14. So we can see that we have the maximum cell number 14 given over here, so which clearly indicates that we need at least a 4x4 K-map, so that the K-map contains a maximum capacity of 16 cells. So again, we just put a K-map, or rather draw a K-map over here. Okay, so I'm just going to draw a K-map right over here. Now it should have 4 rows and 4 columns. 2, there goes. Okay, 3 and 4 rows that we got, just basically got over here. So it also needs 4 columns. Alright, so there you go, we have 4 columns now. Fine, so now let's just number them up over here. Alright, and for the rows, okay, and let the variables, the row and the column variables, be represented as A, B, C, D. So right now we need to number up the cells. So 0, 1, 2, and 3. Then we got 4, 5, 6, and 7. And then you got 8, 9, 10, and 11. And we got 12, 13, 14, and 15 right over here. Okay, so now whenever we're dealing with a POS function, then we should always keep in mind that a 0 represents a non-complementary value, a variable, whereas a 1 represents a complementary variable. So, as I said, each of the numbers that are present over here designate the cell numbers that need to be filled up. Okay, so whenever we're just using a POS function, whenever just we're reducing a POS function with a K-map, we should always fill the designated cells with zeros, contrary to what we've seen for the SOP system. Okay, so let's just put the zeros over here. Okay, I'll just use a different color. So there you go. So we need to fill up cells 1, 2, 3, 6, and 7. So 1, 2, 3, 6, and 7. And then again we have the cells 8, 9, 12, and 14. So let's see, yeah, 8, 9, 12, and then we got 14. So now we can see that in order to group up, we got a quad right over here, a group of 4 consisting of cells 2, 3, 6, and 7. So we just group them up together. Okay, so we got one quad, and then we can also see that we can group up cells 6 and 14 together. So there you go. And also we can group up cells 3 and 1 in pairs of 2. Okay, so now I'd also pass an information to y'all which might be a little startling at the moment. It's always possible to fold a Karnaugh map sideways, something this way. Okay, you can also fold a Karnaugh map sideways like a sheet of paper, and also you can fold it top to bottom, something like this. You can just take the sides and just fold them up together like a sheet of paper, both sideways and as well and top to bottom as well. Okay, so that's why you'll always have the the cells 9 and 1. They will always be adjacent to each other if we just try and fold the K-map from top to bottom. Okay, that is vertically. So in that case, we can just group 9 and the cell number 9 and 1 together in the form of a pair. Okay, and if we just fold the Karnaugh map sideways, okay, horizontally, then we'll have the cells 12 and 14 forming another pair. Okay, so other than that, we can also see that we have the cells 12 and 8, okay, grouped up together, as well as the cells 8 and 9. So we can get to see that we have lots of groups over here. So now if we would just take a good look right over here, then we can basically get to see certain terms. Okay, so if you just take a good look at this particular quad, you can see that well, it has got 2 cells which are not grouped up with any other adjacent zeros. Okay, the grouping system is the same as I had described in the previous example. So over here you can see that there are 2 cells that's just being left alone. That's cell number 2 and 7, and its elements are not grouped up with any other adjacent zeros. So such a group where at least one of these cells are just left alone, and that just cannot be grouped with any other elements, since it has no elements adjacent to itself. So such kind of groups are basically referred to as essential false prime implicants. I'm just going to write it down over here. It's just referred to as essential, okay, false prime implicant. So that's how you just designate such a group whenever it comes to the POS system. Okay, and now we can also see that for all the pairs of groups that we have over here, for each of the pairs, each of their different elements are shared with another element in a separate pair. So all the pairs that we have over here, we will just call them as SFPI, which means selective, okay, selective false prime implicants. All right, there you go. So apart from that, if I would just if I would just go forward and modify the Karnaugh map in a way such that the cells 12, the cells 8 and 9 were just empty, if they were just vacant, then we would never have had the cell number 9 being grouped up with cell number 1 over here. And instead of that, if we would had the cells, let's say 4 and then let's say 10 and 15 filled up, okay, and if the cell number 14 was also not present, if I were to just modify the Karnaugh map somewhat this way, then we would have got a Karnaugh map that would have the elements right in the cells 4, 15 and 10. So in this system, the grouping would have been basically different. Okay, so we would have had the cells number 6 and 4 coming adjacent to each other if we were to fold the Karnaugh map sideways. So if we were to group the cells 6 and 4 together, and then we'd also have had the cell number 7 and 15 being grouped into another pair, and then we also would have had the the cell number 2 and 10 being grouped up in a pair if we were to fold the Karnaugh map upside down. Okay, that's vertically. So in that case, we would have had this particular quad whose elements have all been grouped with other pairs, okay, whose each element is just left vacant, so because they don't have any adjacent elements to group up with. So in that case, we would have had each of these pairs becoming the EPI, okay, whereas the pair itself that the quad group over here that we got would have become an RPI, okay, sorry, RFPI. Okay, that's a redundant, okay, there you go, redundant false prime implicant. All right, so there you go. So that's how you designate these various terms after you just fill up the groups. And if they ask you in any question to just point these out, then you can just do them this way. All right. So you should always keep in mind that each of the groups that are being formed over here for both the in the POS system, all the groups that are just formed over here, each of the groups are just being referred to as a prime implicant, okay, a false prime implicant in each of the groups that are just being made up in the K-map. Okay, so for the SOP system, we just call these groups as false prime implicants. So it doesn't matter whether the groups are pairs or quads or groups of 8, doesn't matter. Whatever groups that you just get over here, they just referred to as false prime implicant. You should always keep that in mind. And for the SOP system of Karnaugh mapping, all the groups that we have over here, each of the groups are just referred to as a prime implicant. All right, it doesn't matter whether the groups are groups of 2 or 4. They're just called prime implicants. Okay, so now that you have learned how to fill up a group using the SOP and the POS system, now you'll also learn how to reduce the expressions using K-map in the forthcoming tutorial. So till then, it's going to be a short goodbye for now, as we're going to wrap up right over here, and you should always keep watching.